Okay, so in this video we're going to figure out the couple ways of measuring the pressure. Okay, the first device will be this tube called the tool called the open tube manometer. And what happens is this: you have some bulb here. Okay, there is a certain amount of pressure in this thing that we need to measure. We want to know what the pressure P is in this system. Okay, so what you do is you attach it to this manometer, which is a U-shaped tube. Okay, that goes like so. Okay, now there is fluid in this U-shaped tube. All right, and we want to know what the pressure P is on this side. So what we know is that on the right hand side is basically exposed to the atmosphere. Okay, so let us say that the height of the liquid above this level here, wherever the device ends, okay, this height of the liquid is nothing but h. Okay, so what we know is that the pressure at these 2 points, let's call this point A, let's call this point B, that the pressure at these 2 points have to be equal if the system is in equilibrium. Okay, and so the pressure at A is nothing but the pressure at B, but the pressure at B, we know already, is nothing but the pressure of the atmosphere plus rho g h. Okay, so the pressure at this location can be determined by the simple equation, okay, that we already know, right? And in order to find the pressure, the gauge pressure of the liquid, of whatever is contained in here, the P gauge is going to be nothing but PA minus the P0, which is rho g h. Okay, so understand that if this pressure here, if the pressure on this side, in this, the unknown pressure rather, if it is greater than the atmospheric pressure, the height h will be above the level B. If it is less than the atmospheric pressure, then the height h will be below the level B. Okay, which will be in this case we'll have to consider that to be negative, and we can figure out whatever the pressure is. Okay, so if it's above B, then we know that the pressure is greater than atmosphere. If it is below B, then we know it is less. Okay, so this is the manometer. Now another device that we have is called the barometer, that you've all heard of. Okay, barometric pressure and all those things. So the barometer essentially is a simple device. What you do is you fill a, okay, so you have, say, some column of mercury, or let's say some unknown liquid. Okay, you take a tube, and you take a thin tube. Okay, and you fill it with this unknown liquid. All right, so you fill it with the same liquid, of the same density rho, and what you do is you invert it, and then you basically put the bottom and the open end into this tube. Now what's going to happen is, when you do this, is that some of the liquid in this tube is going to drain. Okay, so some amount of liquid is going to drain. I'm just going to redraw this again. Some amount of liquid is going to drain, and as a result of this, what's going to happen is there's going to be a little bit of vacuum at the top. Okay, so now what we can do is something really neat. What we know is that the pressure on the outside is nothing but the atmospheric pressure. Okay, and as a result of this, the pressure at that same level throughout, which means the pressure in here, okay, is also equal to the atmospheric pressure. So the pressures are all equal. Okay, now the pressure inside the tube at this bottom, at this location here, okay, let me show you this with the red color. The pressure here is due to the column of the liquid. Okay, and that pressure is nothing but the atmospheric pressure. So this is nothing but the pressure due to the column of the liquid, which is rho g h, and nothing but the gauge pressure because of the vacuum, because there's vacuum above it, so that does not contribute to any pressure out here. And so what we know is that the pressure at this red mark in the fluid, which is simply the gauge pressure, okay, has to be equal to the atmospheric pressure. So this is one way of determining the atmospheric pressure. If you do not know what the atmospheric pressure is, then we can do this. Now typically what we have to understand is that we would like to use a liquid with as high a density as possible, because the higher the density of the liquid, then the lower the size of the barometer that we need. Okay, if we were to use water, for instance, okay, then you will see that the height of the liquid that is required is going to be about 10 meters or so. Okay, because that is the amount of water that is required for you to experience a pressure of 1 atmosphere. Okay. On the other hand, the liquid that is typically used in thermometers, in barometers, is mercury, and the density of mercury is about 13,600 kg per meter cube. Okay, and what is observed is that about 76 centimeters of mercury, okay, is required to balance this atmospheric pressure under standard conditions. Okay, and this height therefore can be calculated using the equation P0 over rho times G, which is we can calculate the atmospheric pressure P, okay, using this equation, which is rho GH. Rho is 13,600 times 9.8 times about the height, which is 76 centimeters, 0.76, and you get a value of 1.01 times 10 to the 5 pascals. Okay, now on the other hand, if you were to use water to measure the same pressure, the amount of water that you would require, the height of, say instead if you were to use water, okay, then the height of water required would be equal to 1.01 times 10 to the 5, which is P0, and that would divide this by rho times G. The density of water is about this. Okay, and if you calculate this would lead to about 10.2 meters of water. So you need a really tall barometer to do this. To be able to, if you were to use water as a liquid instead of mercury. Okay, so mercury really works out, and we're able to make we're able to use that to figure out the atmospheric pressure. Okay, so that's all about pressure measurements.